Advanced Concrete is part of the Graitec structural beam solution. It is an easy-to-use modeling and detailing software solution for reinforced concrete structures, completely integrated into AutoCAD. Advanced Concrete was specifically designed for engineers and structural draftsmen looking for a program that automatically generates construction drawings, reinforcement drawings, material lists and NC files. We begin the modeling of a structure with 2 levels and a ground floor by placing the grid. This structure does not raise major modeling problems, but we have chosen this type of building to briefly emphasize the main functionalities of Advanced Concrete. In the grid properties, we can modify the distance between the axes and the 2 directions, or we can modify the axis representation. We will first model the columns. We select the 40-40 rectangular section and the material. Then, we define the first row of columns. Using the AutoCAD commands, we can copy the columns at the intersection of the other axes. We proceed similarly when modeling the beam. We define the first row of beams on the vertical direction of the sheet. And then we copy them to the other axis. On the perpendicular direction, we define the structural walls. We set a thickness of 20 cm and we define the first row of walls. In the same way, using the AutoCAD commands, we copy the walls to the horizontal axis. We define the slab contours using points. We select a thickness of 15 cm. We position a few types of holes in the vertical walls. We can easily set parameters for the holes in the properties list. We define window holes in the exterior walls. And a few door holes in the interior walls. All elements have been created in the ground floor system. Once the elements from the first level have been created, they can be multiplied on the vertical direction. From the Properties window, we can also change the height of the level. The upper dimension of the first level will be automatically modified. We create the second level by using the multiplication function. The footings are generated in the basement system. The footings can be positioned by taking into consideration various criteria. We set the dimensions of the isolated footings and the dimensions of the continuous footings under the walls. We generate the footings automatically. In the next step, we create isometric views, formwork plans and reinforcement drawings. We generate an isometric view. The isometric view can be separately viewed in a new drawing. Returning to the first level, we will create a few sections. We draw a section line on the plan view and we set the view depth. The section will be automatically created in a separate drawing by simply double-clicking. We use the specific functionalities for dimensioning offered by Advanced Concrete. We use the intersection dimension that automatically creates a dimensions row between all elements cut by the dimension line. The intersection dimension can be used horizontally and vertically. We continue by positioning the level dimension, starting from the level of the upper slab. The dimensions will be referred to the current section, AA. In other cases, we can also represent sections by using polygonal lines. Next, we create the formwork plan from the elements of a level. We select first for the elements the viewing mode from top to bottom. In a separate drawing, the formwork plan is automatically created. In Advanced Concrete, an intelligent dimensioning tool is the associative dimension. By selecting all elements on a structure axis, the rows with necessary dimensions are automatically created. On this formwork plan, we select all elements of beam type. From the properties list, we select the option for the automatic creation of sections. The sections are placed directly on the elements. They are automatically created on the already existing drawing. We can use the same dimensioning tools, the same intersection dimension, but also the level dimension. The creation of the reinforcement drawings represents an important part in the process of creating a structure. Generally, the reinforcement drawings creation demands a lot of time, attention, patience and responsibility, and the issued drawings must conform to specific standards. In this context, Advanced Concrete offers a set of reinforcement tools that can be easily adapted to the necessities of each project. 1. The parametric reinforcement allows creating reinforcement details for standard structural elements in a simple and intuitive way. 2. The manual reinforcement allows adapting and obtaining reinforcement details for any type of structural element. And 3. The dynamic reinforcement represents a new concept in the modeling and detailing of reinforced concrete structures that significantly accelerates the reinforcement drawing creation by automatically placing reinforcement with drawing update after each modification made to the model. The dynamic reinforcement solutions allow the fast reinforcement of standard elements, beams, columns, footings, slabs, taking into consideration their context, such as the element's intersection, and also the reinforcement of prefabricated elements. Using Advanced Concrete dynamic reinforcement, the elements from a detail can be saved and then applied to other groups of similar elements of different dimensions after modifying the key parameters. After creating the formwork plans, we will exemplify the main ways of reinforcing concrete elements. In this case, we will use the parametric reinforcement for a column. From the properties list, we select the section shape. Then, we use the reinforcement details for the main bars, the secondary bars, stirrup bars and their distribution. By selecting a column, we generate a reinforcement drawing. In the new drawing, we will view the reinforcement of the element. The bars were automatically associated with reference marks. We can also view the reinforcement cage in the 3D viewer mode. the cage can be saved, and then insert it in the drawing that contains the column reinforcement. On these drawings, we create a bar list. The list contains all necessary information, including the bar details. Next, we will shortly exemplify the manual reinforcement of a beam. First, we select the beam, and then we generate a format plan that can be viewed in a separate drawing. Like in the previous drawing, the format plan is represented on the elevation, on the top view, and on the section. On the elevation view, we define the longitudinal bars by taking into consideration the formwork edges. We position first the bar on the upper side of the beam. From the bar properties list, we can modify the anchor length, or we can add hooks. We proceed similarly when defining the bar on the lower side of the beam. In the beam section, we draw a rectangular frame using the section edges as reference points. We select for the rectangular frame a diameter of 10 mm. Each reinforcement bar that was defined is automatically associated with a reference mark. To number them, we must distribute the definition bar. We start first with a point distribution of the longitudinal bars on the beam section. Once the bar was distributed with the 3D power function, the bar is automatically generated in the other views. We continue with the rectangular frame distribution on the elevation. The distance between the rectangular frames can be set by taking into consideration different types of distribution. We select the quantitative distribution, through which the number of necessary rectangular frames on the central area of the beam is automatically determined. We automatically generate bar details for all bars. Finally, we generate a collision check for the reinforcement bars. The collisions can be rapidly identified using the 3D view function. Through the collision check, we discover that there is a collision between the hooks of the longitudinal reinforcement. The bar details are instantly updated after making these modifications. When repeating the collision check, we notice that there is no more error. Next, we can add a 3D representation of the reinforcement formwork to the drawing. We add a bar list with bar details. Next, we reinforce a wall supported by 2 columns using the dynamic reinforcement concept. From the Reinforcement Solutions library, we select a solution appropriate for this case. In the Properties list, we modify the parameters that will be reflected in the details of the reinforcement drawing. We select the specific elements for applying the solution, the wall, and the 2 columns. In the same manner, we apply individually for the columns the corresponding reinforcement solution according to the dynamic reinforcement type that we wish to apply to these elements. We select the 3 elements and we create a new reinforcement drawing. In a new drawing, we can view the reinforcement of the elements on the elevation, on the section, and also on the top view. The great advantage of this type of reinforcement is that by modifying the element's dimensions, the reinforcement drawing is automatically updated. For example, we can modify the dimensions of a column. After updating the reinforcement drawings, the reinforcement formwork will be automatically updated to the new dimensions of the formwork. We generate a bar list. We also insert in this drawing a 3D representation of the reinforcement and then to create the final reinforcement drawings, we must only select a standard layout. We set the dimensions of the layout frame and the content of the title block. Then we insert the drawing in this layout. In this presentation, we only offered a short overview of the main functionalities of the modeling and detailing solution for reinforced concrete structures, Advanced Concrete. For more information, please do not hesitate to contact a Graitec representative.